In a secure facility deep within Tokyo during the final week of March in 1943, three Japanese naval intelligence officers examined a collection of photographs that would fundamentally challenge everything they understood about modern warfare and industrial capability. The room was windowless, lit by overhead lamps that cast harsh shadows across a polished wooden table. Commander Tao Yoshikawa and his two colleagues from the Naval General Staff's intelligence division had received reconnaissance images captured by one of their submarines operating dangerously close to the California coastline just 2 weeks prior. The submarine had surfaced briefly, risking detection, to extend its periscope camera above the waterline. The captain had initially believed he was documenting the construction of a new American aircraft carrier at what appeared to be a major shipbuilding facility. The photographs his crew risked their lives to obtain showed something entirely different, though far more significant than anyone aboard that submarine could have realized at the time. What the photographs actually revealed was a vessel that defied every convention of naval architecture these experienced officers had studied throughout their careers. The ship captured in these grainy black and white images stretched approximately 300 feet in length, featuring a completely flat and open deck that ran almost the entire length of the vessel. Most striking was the unusual bow section that appeared designed to open like an enormous gate or door, a feature none of them had encountered in any naval vessel from any nation. The hull construction was remarkably simple, almost brutish in its lack of refinement. There were no elegant curves, no sophisticated hydrodynamic considerations visible in the design. It was crude, utilitarian, built for function rather than form. There was minimal superstructure, just a modest bridge mounted along the starboard side, looking almost like an afterthought attached to the massive hull. The vessel appeared more like an industrial barge than a military ship, yet it was clearly under construction at a military shipyard with evident priority. However, what truly captured the attention of these three experienced intelligence officers, men who had spent years analyzing naval capabilities and ship construction programs, was not the unusual design of this single vessel. In the background of the primary photograph, partially concealed by the vertical lines of harbor cranes and the angular shadows of warehouse structures, they could identify at least 6 additional identical vessels in various stages of assembly. Some appeared to be just beginning construction, with only the basic keel and frame visible. Others seemed nearly complete, their hulls already taking final shape, and this was merely one shipyard among many scattered along America's vast coastline. The implications began to dawn on them as they studied the images more carefully. Yoshikawa, the senior officer present, retrieved another folder from a locked filing cabinet. Inside were intelligence reports that had accumulated over the previous 8 months, each one seeming insignificant on its own, but together forming a troubling pattern. A naval attaché who had been stationed in Argentina had filed detailed observations about unusual American maritime activities in the months before his diplomatic recall. His reports mentioned increased ship traffic, unusual procurement patterns, and rumors of massive construction programs. Japanese cryptographers, working in another section of the building, had intercepted and successfully decoded American logistics communications 3 months earlier. These decrypted messages referenced something called an LST program, with production targets that seemed not just ambitious, but utterly impossible by any reasonable standard of naval construction. The numbers mentioned were so high that the cryptographers had initially suspected an encoding error or deliberate disinformation. Through the Axis intelligence sharing arrangement with Nazi Germany, Japanese analysts had also received German intelligence summaries. These reports noted unusual and intensive construction activities at shipyards along America's eastern seaboard and throughout the Gulf of Mexico region. German agents had observed massive movements of steel, the hiring of thousands of workers, and the expansion of shipyard facilities at a pace that suggested something extraordinary was underway. None of these individual reports had triggered particular alarm when initially received and filed. After all, everyone in naval circles throughout the world understood the fundamental truth that ships required years to construct. This was not opinion or theory, but demonstrated fact, proven over centuries of naval warfare and shipbuilding. Capital warships, the massive battleships and aircraft carriers that determined naval supremacy and controlled the seas, demanded enormous investments of both time and material resources. A single battleship could take 4 or 5 years from initial keel laying to final commissioning and operational deployment. This was not merely Japanese doctrine or practice, but universal truth accepted by every major naval power throughout the world. The British, the Americans, the Germans, the Italians, all operated under the same constraints and limitations. The construction of a warship was an intricate process, requiring thousands of workers with specialized skills. The hull alone demanded expert metalworkers who could shape thick steel plates into complex curves. The propulsion systems required master engineers who understood turbine technology. The electrical systems, fire control mechanisms, weapons installations, and countless other components each needed their own specialists. Training these workers took years. Coordinating their efforts required careful planning and management. Yet these vessels in the photographs were clearly not capital ships in the traditional sense. They were something entirely different, something that didn't fit into established naval categories. The Americans were apparently designating them as landing ships, vessels engineered specifically to transport tanks, trucks, and combat troops directly onto hostile beaches during amphibious assault operations. These ships could intentionally beach themselves, running directly onto the sand or coral, then discharge their cargo of vehicles and troops before withdrawing with the next high tide. It was an audacious concept, deliberately running a large vessel aground in a controlled manner, something that went against every instinct trained into naval officers. The concept of specialized landing vessels was not entirely revolutionary or unprecedented. The Imperial Japanese Navy operated its own landing craft and had pioneered amphibious assault techniques during operations in China and throughout the Pacific. But those were relatively small vessels, typically capable of transporting perhaps a single tank or a company of infantry soldiers, roughly 100 to 150 men. They were essentially large motorboats with reinforced hulls and bow ramps. These American ships, if the preliminary intelligence assessments were anywhere close to accurate, could carry 20 full-size tanks each. Not light tanks, but medium tanks like the Sherman, each weighing 30 tons. Or alternatively, they could carry 40 trucks with all their associated equipment and supplies, or 500 fully equipped soldiers with their weapons, ammunition, rations, and combat gear. The cargo capacity was staggering, representing a fundamental leap in amphibious capability. Yoshikawa performed rapid calculations in his head, his mind working through the strategic implications. If the Americans were constructing these enormous vessels at multiple shipyards, if each facility was producing them at even a fraction of the rate suggested by the intercepted logistics communications, if the construction timeline was as remarkably brief as the decoded messages implied, then within 12 months, the United States would possess amphibious assault, capabilities that exceeded anything the Imperial Japanese Navy had ever contemplated or planned. For the strategic implications were genuinely staggering when fully considered. Every island Japan had spent years fortifying throughout the vast Pacific could potentially be assaulted with overwhelming force. Every garrison that relied on geographic isolation and distance for its defense would suddenly face an enemy capable of bringing massive military power directly onto the beaches. Not gradually through vulnerable and time-consuming small landing craft operations, with troops arriving piecemeal over hours or days, but in concentrated and coordinated waves of armor and infantry arriving simultaneously in crushing strength. Japanese defensive doctrine assumed attackers would be vulnerable during landing operations, strung out in small boats, exposed to defensive fire. These ships changed everything about that calculation. That afternoon, as shadows lengthened across Tokyo, Yoshikawa composed his assessment with meticulous care. He chose his words carefully, aware that his report would be read by senior officers who might not appreciate alarming conclusions. The report proceeded through proper bureaucratic channels to the Naval General Staff headquarters, passing through multiple hands and offices. It was read by several officers, each adding their own commentary and assessment. It was officially filed in the appropriate folders, stamped and catalogued, and then it was largely dismissed, set aside without the urgent action it warranted. The reasoning employed by the officers who made this decision seemed entirely logical, straightforward, and based on decades of naval experience. America certainly possessed enormous wealth. The economic capacity of the United States was undoubtedly vast, perhaps the largest in the world. American industrial output in peacetime had been remarkable, producing automobiles, aircraft, and countless consumer goods in impressive quantities. But ships were different. Ships were not automobiles that could be stamped out on assembly lines. Ships required time to construct, vast amounts of time. Ships required skilled labor, men who had spent years learning their trades through traditional apprenticeship systems. Ships required resources, steel and engines and equipment that necessarily had to be diverted from other wartime priorities. Every ton of steel used for these landing ships was a ton not available for building carriers or battleships or cruisers. The photographs showed vessels under construction, skeletal frames and incomplete hulls, not finished operational ships ready for combat deployment. Even the Americans, with all their celebrated industrial capabilities and manufacturing prowess, could not simply materialize a fleet of landing ships into existence through wishful thinking or propaganda. There were physical limitations, bottlenecks in production, constraints on skilled labor. Naval warfare operated according to established rules that had been proven over centuries. Construction had inherent limits that could not simply be ignored or overcome. Everyone who understood naval matters, who had studied maritime history and ship construction, knew this fundamental truth. These were serious, experienced officers making rational decisions based on the best information available and their extensive professional knowledge. They were catastrophically, tragically wrong. Their expertise had become a liability, blinding them to a paradigm shift in industrial warfare. What Yoshikawa and his colleagues had witnessed in those reconnaissance photographs was not merely an ambitious shipbuilding initiative or an optimistic production program. It was the opening phase of the largest, fastest, and most ambitious maritime construction effort in human history, a transformation of shipbuilding from craft to industry. The terrible truth would only become clear much later, when American landing ships began appearing in Pacific waters in numbers that seemed impossible, when it was far too late to alter the strategic situation or adjust Japanese defensive planning, to understand why highly intelligent and experienced Japanese naval officers could not grasp what they were observing in those photographs. One must first understand what naval warfare had represented for centuries, since the age of sail and wooden ships through the modern era of steel and steam. Ships were precious assets, irreplaceable treasures. Ships were extraordinarily expensive, consuming enormous portions of national budgets. Ships required years to design, with naval architects spending months creating detailed plans and specifications, and additional years to construct, with thousands of workers laboring over every detail. This was not solely Japanese military doctrine or a peculiar belief of the Imperial Navy. This represented universal truth, confirmed by every major navy throughout the world, from the Royal Navy to the United States Navy to the French and Italian fleets. The fundamental economics and physics of shipbuilding were understood to be constant across all nations. Prior to the Second World War, the construction timeline for a capital ship, whether a massive battleship or a fleet carrier capable of launching dozens of aircraft, typically ranged from 3 to 5 years from the ceremonial initial keel laying to final commissioning and operational deployment. Some ships took even longer when construction was delayed by budget constraints or technical challenges. The Imperial Japanese Navy's Yamato, the largest and most powerful battleship ever constructed by any nation, mounting 18-inch guns capable of firing shells over 25 miles, required 4 full years of intensive construction. The ship consumed resources equal to several smaller vessels, and its construction strained Japan's industrial capacity significantly. HMS Hood, the pride of the Royal Navy and the largest warship in the world when completed, took 3 years of continuous construction. The ship represented the pinnacle of British naval engineering and craftsmanship, with every detail carefully considered and executed. The American carrier USS Enterprise, commissioned in 1938 and destined to become one of the most decorated ships in United States naval history, spent nearly 3 years under construction at the prestigious Newport News shipbuilding facility in Virginia. The carrier was a marvel of modern naval architecture, but even with American industrial capability, it could not be rushed. Even smaller vessels demanded substantial construction periods and significant resources. Destroyers, the workhorses of any modern naval fleet, fast and maneuverable vessels used for screening larger ships and hunting submarines, needed 12 to 18 months of construction time under normal circumstances. These were relatively simple ships compared to battleships or carriers, displacing only 2,000 tons and mounting modest armament, yet they still required over a year to build. Submarines required similar extended periods, though for different reasons. The pressure hull had to be precisely constructed to withstand the enormous forces of deep diving. The complex machinery, electrical systems, and weapons installations all demanded careful integration. Building a submarine was as much art as engineering. The notion that a useful military vessel, something capable of crossing oceans and surviving combat conditions, could be constructed in weeks rather than months, or months rather than years, contradicted everything that naval architects and military planners understood about shipbuilding principles and limitations. It seemed to violate the fundamental constraints of metallurgy, engineering, and human labor. This deep understanding of shipbuilding realities profoundly shaped Japanese naval strategy in the years leading up to the war and during the conflict itself. The Imperial Japanese Navy had entered the war with approximately 350 major combat vessels, including cruisers and larger warships. This fleet represented the accumulated result of decades of continuous construction effort, enormous financial investment consuming significant portions of national budgets, and the accumulated expertise of Japan's limited but sophisticated heavy industrial base. Every ship in that fleet was precious because every ship was essentially irreplaceable in any meaningful time frame, or at best, replaceable only after years of intensive effort that would strain resources and divert capacity from other urgent needs. Losing a heavy cruiser meant that cruiser was gone, likely for the duration of the war. Losing a carrier was a catastrophe that could not be remedied for years. This understanding fundamentally informed Japanese war planning during the late 1930s and early 1940s, as tensions with the United States increased and conflict became increasingly inevitable. The Navy would strike first in a devastating blow, crippling American naval power at Pearl Harbor and destroying the Pacific Fleet before it could sortie and oppose Japanese operations. The attack would be coordinated and overwhelming, designed to sink or damage as many capital ships as possible in a single morning. Then, in the months that followed while America reeled from the attack, Japanese forces would rapidly secure a vast defensive perimeter throughout the Pacific and Southeast Asia. They would seize the Philippines, cutting off American forces there. They would capture the Dutch East Indies with its vital oil resources. They would fortify strategic islands, creating interlocking zones of control, each position supporting the others. American forces, bleeding from their initial catastrophic losses and struggling with shattered morale, would require years to rebuild their shattered fleet to pre-war strength. Carriers took years to build. Battleships took even longer. By the time American forces were prepared and ready to mount a counteroffensive, by the time they had replaced their losses and constructed new ships, Japan would be impregnable behind its defensive perimeter, with every island turned into a fortress. The mathematical logic seemed sound when examined carefully. America's industrial capacity was certainly larger than Japan's, perhaps 3 or 4 times larger in terms of raw output. But that enormous capacity required substantial time to convert from peacetime production of consumer goods to military output of weapons and ships. Factories had to be constructed or converted from civilian production. Workers had to receive extensive training in new skills. Supply chains had to be established and tested. Raw materials had to be secured from domestic and foreign sources and distributed efficiently. All of this necessarily took time, perhaps years to fully accomplish. Japan had been preparing for war for over a decade, gradually building up its military capabilities. America would be starting from relative peacetime readiness. During that extended conversion period, while America tooled up for war production, Japan would utilize its initial advantage to create defenses so formidable that American forces could not overcome them, even with superior numbers. This strategic analysis was not irrational or based on wishful thinking. It was grounded in solid historical precedent and sound military reasoning. Japan had successfully executed similar strategies in previous conflicts, notably in the Russo-Japanese War of 1904 to 1905, where Japan's initial devastating attack on the Russian Pacific fleet at Port Arthur had set the conditions for ultimate victory. What Japanese planners completely failed to anticipate was not merely that America would mobilize faster than expected, though that turned out to be true. What they absolutely failed to anticipate, what no one could have predicted based on historical experience, was that the fundamental rules and constraints of naval construction were about to undergo revolutionary transformation. The ancient craft of shipbuilding was about to become an industry. The Americans were not planning to build ships using traditional methods, with traditional techniques practiced over centuries, on traditional timelines that everyone understood and accepted. They were about to industrialize shipbuilding itself, applying the same mass production techniques that had revolutionized automobile manufacturing in the 1920s and 30s to the construction of military vessels. Ships were about to become products, manufactured rather than crafted. The United States entered the Second World War, confronting a critical strategic challenge that was immediately apparent to military planners. To defeat Japan, American forces would need to cross the Pacific Ocean, the largest body of water on Earth, covering nearly 64 million square miles. They would need to assault fortified islands defended by experienced and determined troops who had spent months or years preparing defensive positions. And they would need to sustain complex military operations thousands of miles from the nearest major supply base in Hawaii or the West Coast. Every previous major war in human history had been fought over land, where armies could march to battle, carrying their supplies in wagons and living off the local countryside when necessary. Or wars had been fought across relatively short sea distances, where naval forces could operate in relatively close proximity to their home ports and could return for resupply within days or weeks. Even the First World War, despite its global scale, had been primarily a land war fought across continuous front lines. The Pacific War would be fundamentally different from anything in military history. Islands like Tarawa, a tiny atoll barely visible on maps, Saipan in the Marianas, Iwo Jima with its volcanic soil and caves, and Okinawa approaching the Japanese home islands, all lay thousands of miles from American ports and bases. Some were over 5,000 miles from San Francisco, requiring weeks of travel by ship. Capturing these islands would require landing substantial military forces, entire divisions of troops, directly onto hostile beaches, while under enemy fire from prepared positions. Those troops would need not just rifles and ammunition, but heavy equipment. They would need tanks to break through fortified positions. They would need artillery pieces to provide fire support. They would need trucks and jeeps for transportation and logistics. They would need vast quantities of ammunition, fuel, food, medical supplies, and countless other materials necessary to sustain combat operations. Traditional naval logistics systems, evolved over centuries of warfare, could not solve this problem effectively or at the scale required. Before the war, amphibious operations relied on what the Navy termed boat waves, a time-consuming and vulnerable process. Troops would transfer from large transport ships anchored offshore, climbing down cargo nets while laden with equipment, into small landing craft bobbing in the waves below. These craft, typically capable of carrying 30 to 40 men, or a single light vehicle like a jeep, would motor toward the beach in organized waves, discharge their passengers who would wade through the surf, and then return to the transport ships for another load. The entire process was slow, taking hours or even days to land a full division. It was extremely dangerous, with troops exposed during the vulnerable transfer and approach, and it was inherently limited in scale, constrained by the number of landing craft available. The historical example that haunted military planners was Gallipoli in 1915, where British, French, and Anzac forces had attempted a major amphibious assault against Turkish defences along the Dardanelles. The operation became a catastrophic disaster that was studied in every military academy. Landing forces became trapped on narrow beaches, unable to bring sufficient heavy equipment ashore to break through the defensive positions that the Turks had prepared on the heights above. Without armour support, without sufficient artillery, pinned down by machine gun and rifle fire from entrenched positions, the assault forces could not advance. They could not retreat as the sea was behind them. They simply bled, suffering horrific casualties over months of futile attacks. The eventual evacuation was the only successful part of the entire operation. The total casualties exceeded 250,000 men from all sides. The lesson from Gallipoli seemed brutally clear to anyone who studied military history. Amphibious assaults against prepared and determined defences were nearly impossible without overwhelming superiority in numbers and firepower, and critically, the ability to rapidly build substantial combat power ashore before defenders could concentrate their forces and counterattack. Getting troops onto a beach was not enough. They needed their tanks, their artillery, and their supplies immediately, not hours or days later. American military planners studying Pacific geography during the late 1930s and early 1940s, as war clouds gathered and conflict with Japan became increasingly likely, recognized they would face this exact problem repeatedly. Japan controlled and had fortified dozens of strategic islands scattered across millions of square miles of ocean. Each island would require assault if America was to advance across the Pacific. Each assault would need to put thousands of troops ashore quickly, along with their armor and artillery support, fast enough to establish a secure beachhead before Japanese defenders could organize effective counterattacks. Traditional landing craft, no matter how many were built, could not accomplish this with sufficient speed or concentration of force. The mathematics simply didn't work. A typical landing craft carrying 40 men would need to make dozens of trips to land a single battalion of 800 men. Landing the tanks and artillery would take even longer, as each piece of heavy equipment required its own dedicated landing craft or multiple craft. The solution to this seemingly impossible problem emerged from an unexpected source during a time of desperate innovation. In 1941, as Britain fought alone against Nazi Germany and struggled to consider how it might eventually return to the European continent, a British officer visiting the United States mentioned a radical concept the Royal Navy was exploring in its planning offices. They called it a landing ship tank, a designation that described its function directly. The vessel would be large enough, essentially a small cargo ship, to carry multiple tanks and vehicles in its cargo hold, rather than just one or two. It would feature a bow door that could open, a revolutionary feature never before incorporated into an ocean-going vessel, allowing vehicles to drive directly onto a beach under their own power. The ship itself would beach intentionally in a controlled grounding, becoming a temporary bridge from sea to land, then withdraw when its mission was complete. American naval architects and Marine Corps planners, already wrestling with the amphibious assault problem, immediately recognized the concept's enormous potential. This could solve the problem of getting armor ashore quickly, but they also immediately recognized the immense scale of the challenge they faced. To conduct multiple simultaneous amphibious operations across the vast Pacific, operations that might be happening thousands of miles apart, the Navy would need not dozens of these ships, which might be manageable, but hundreds, perhaps ultimately thousands of these specialized vessels, and they would need them quickly, within 2 or 3 years at most, not the 5 or 10 years that traditional naval construction timelines would require. The war would not wait for ships to be built at peacetime rates. Every month without these capabilities was a month Japan could strengthen its defenses. The fundamental question facing American military and industrial leaders in early 1942, as the nation reeled from Pearl Harbor and mobilized for total war, was straightforward in its statement, but daunting in its implications. Could the United States design, develop, and mass-produce a completely new type of military vessel, something that had never existed before, on a scale unprecedented in naval history? Could they accomplish this fast enough to actually impact the war's outcome? Or would the ships arrive too late to matter? And most challenging of all, could they do it while simultaneously building fleet carriers to replace those lost at Pearl Harbor, battleships to restore American naval power, destroyers for convoy escort duties, submarines for the Pacific War, Liberty ships to carry supplies to allies around the world, and the thousands of aircraft, tanks, and other weapons the war effort required across multiple theaters? The scale of the challenge seemed overwhelming. America would need to expand its shipbuilding capacity beyond anything previously attempted. The answer to these questions would ultimately reshape not only the Pacific War's outcome, but the entire future of amphibious warfare doctrine and naval construction methodology for decades to come. The landing ship tank designation, universally abbreviated as LST in naval communications and documentation, emerged from an intensive design competition that began in earnest during February of 1942. The Navy's Bureau of Ships, responsible for all naval vessel design and construction oversight, issued specifications that seemed almost contradictory, even paradoxical, in their requirements. The vessel needed to satisfy multiple conflicting demands simultaneously. The vessel needed to carry at least 20 medium tanks, the M4 Sherman that was becoming the standard American medium tank, or their equivalent weight in other vehicles and cargo. Each Sherman weighed approximately 30 tons, meaning the cargo capacity needed to exceed 600 tons. It needed to cross oceans under its own power, not requiring a tow from other vessels, which meant it needed engines, fuel capacity, and seaworthiness to handle rough weather over voyages of thousands of miles. It needed to beach itself on typical Pacific Island shorelines, which meant operating in as little as 3 feet of water at the bow, an incredibly shallow draft for a vessel of this size. It needed a bow door and ramp system that could deploy quickly and reliably under combat conditions, potentially while under enemy fire. And crucially, perhaps most importantly for the program's success, it needed to be simple enough in design and construction that relatively inexperienced shipyards, Facilities that had never built military vessels before could build it in large numbers without extensive training or specialized equipment. John C. Niedermeyer, a talented naval architect working for the Bureau of Ships in Washington, led the design team assembled to solve this problem. His challenge was essentially impossible by traditional naval architecture standards and principles. The requirements contradicted fundamental principles of ship design that had been established over centuries. Ocean-going ships, vessels designed to cross open oceans safely, had deep drafts with keels that extended well below the waterline for stability in rough seas. The keel acted like a fin, preventing the ship from rolling excessively and providing directional stability. Deeper keels meant better stability, but also meant the ship needed deeper water to operate. Beaching vessels, craft designed to run up onto shores, were traditionally flat-bottomed with very shallow drafts, allowing them to operate in just a few feet of water. But such designs were inherently unstable in open ocean conditions. They rolled dangerously in even moderate seas and could not maintain course effectively in strong winds or currents. They were coastal craft, never intended for open ocean voyages. Niedermeyer needed a ship that could somehow do both, be stable enough for ocean crossings and shallow enough for beaching operations. These seemed like mutually exclusive requirements. His solution was inelegant, even crude by traditional standards, but brilliantly functional and practical. The LST would have a flat bottom for beaching operations, but would incorporate large ballast tanks running along both sides of the hull that could be flooded with seawater for ocean crossings, dramatically increasing stability by lowering the center of gravity. When approaching a landing beach for assault operations, powerful pumps would empty these ballast tanks, reducing draft from roughly 14 feet when fully loaded to less than 4 feet forward. This would allow the ship to drive directly onto the beach. The bow would be blunt and squared off, rather than the traditional pointed bow, designed to ground firmly and stably on sand or coral. The flat bottom would distribute weight evenly, preventing the ship from digging in or tipping. 2 massive clamshell doors, each weighing several tons, hinged on the sides of the bow, would swing open outward like gates. Behind them, a heavy steel ramp would lower hydraulically, creating a bridge from the ship's interior cargo deck directly onto the beach. Tanks could drive off under their own power within minutes of grounding. The final dimensions were substantial, creating one of the largest standardized vessels ever mass-produced. The design measured 328 feet in length, longer than a football field, and 50 feet in beam, providing enormous internal volume. Displacement when fully loaded with cargo, fuel, and crew reached approximately 4,000 tons, making it larger than many pre-war destroyers. The cargo deck, running nearly the entire length of the ship with minimal obstruction, could accommodate 20 Sherman tanks parked side by side in 2 rows down the center line. The ceiling height allowed even tall vehicles to fit comfortably. Alternatively, the deck could carry 27 2.5-ton trucks, the standard American military cargo truck, or it could carry nearly 200 tons of general cargo, ammunition, supplies, or equipment loaded in various configurations, or any combination of vehicles and supplies the mission required, providing enormous flexibility for different operations. The propulsion system utilized 2 General Motors diesel engines, 12-cylinder units producing 900 horsepower each, adapted from locomotive engines already in mass production. These drove twin propeller shafts extending from the stern. Maximum speed was approximately 12 knots, roughly 14 miles per hour, which sounds slow and indeed was painfully slow by any naval standards. To put this in perspective, most cargo ships could make 15 to 18 knots. Combat vessels like destroyers routinely operated at 30 knots or more. Battleships and carriers could make 25 to 30 knots when needed. The LST was slower than almost any ocean-going vessel afloat. But speed was deliberately not the priority in the design. Reliability mattered more than speed. Simplicity of maintenance mattered more than performance. Cargo capacity mattered far more than speed. An LST that arrived a day later but delivered its cargo safely was far more valuable than a faster ship that broke down or required constant maintenance. The crew complement was typically 113 officers and enlisted men, a relatively small crew for a ship of this size, made possible by the simple systems and limited equipment. Accommodations were basic and Spartan, nothing remotely resembling the relative comforts found on a cruiser or battleship. Men slept in cramped berthing areas with stacked bunks. Officers had tiny cabins. The mess facilities were minimal. This was a working ship, not a warship in the traditional sense. The ship carried defensive armament for protection, typically 8 20mm anti-aircraft guns mounted in pairs and 2 40mm guns in twin mounts. But these were intended only for self-defense against aircraft attack. LSTs were not combat vessels designed to fight other ships. They had no torpedo tubes, no heavy guns, no armor protection. They were essentially floating trucks designed to carry cargo from port to beach, deliver it safely, and return for another load. Construction methodology and technique were equally important as the design itself in making mass production possible. Traditional shipbuilding, the method used for centuries and still employed for capital ships, started with a keel, the spine or backbone of the vessel laid down in a dry dock or on a slipway. This was usually a solemn ceremony with dignitaries present. Workers would then build the frame outward and upward from this keel, adding ribs and structural elements in a specific sequence, creating the skeleton of the ship. Eventually, they would plate the exterior with steel sheets, riveted or welded in place. The process was inherently sequential, with each step necessarily depending on completion of previous steps. You couldn't install the engines until the hull was complete. You couldn't add superstructure until the deck was finished. It required highly skilled workers, craftsmen really, who had spent years learning their trades through traditional apprenticeship systems. These men understood complex three-dimensional structures intuitively and could work metal into compound curves and complex shapes. Such workers were relatively rare and took years to train properly. The LST design deliberately avoided this traditional complexity wherever possible. The hull was constructed in prefabricated sections that were largely flat or incorporated only simple curves that could be formed with basic equipment. These sections could be built simultaneously in different parts of a single shipyard, or even at entirely different locations hundreds of miles apart, then transported to a final assembly site where they would be welded together. This parallel construction method dramatically reduced build time. While one section was being built, another was being fitted with equipment, and a third was being transported. Welding replaced riveting wherever possible throughout the design. Welding required less specialized skill than riveting and was faster. A welder could be trained in weeks or months, while a skilled riveter required years of practice. American forces possessed the equipment, supplies, ammunition, and replacement personnel to sustain intensive operations indefinitely. Japanese forces, completely cut off from any hope of resupply or reinforcement from the home islands, gradually and inevitably exhausted their ammunition stockpiles and other resources. The end was mathematically certain from the start. The LST program's final tally was staggering by any measure and represented an achievement unprecedented in naval history. Between 1942 and 1945, American shipyards across the nation constructed 1,051 LSTs. The peak production year, 1944, saw 736 vessels completed and commissioned. This represented more than one complete ship per day, every single day without exception, for an entire calendar year. The total tonnage represented more than the entire Japanese Navy possessed at the start of the war in December 1941. But the raw numbers, while certainly impressive, tell only part of the larger story about American industrial mobilization. The LST program conclusively demonstrated that modern industrial nations could, when properly mobilized with political will and coordination, produce military equipment at scales that would have seemed completely impossible in previous conflicts throughout history. The factories, workers, organizational systems, and logistical networks that built LSTs also simultaneously built Liberty ships by the hundreds, Victory ships, escort carriers converted from merchant hulls, destroyers, landing craft of various types, and thousands of other vessels. American shipyards delivered over 5,000 major military and cargo vessels during the war years from 1941 through 1945, utterly transforming the United States into a maritime power of unprecedented scale that dominated both oceans. For Japan, the lesson about industrial capacity came far too late to matter strategically or alter the war's outcome. By the time Japanese military leadership at the highest levels fully understood and internally accepted the implications of American industrial mobilization and what it meant for Japan's prospects, reversing course was politically and psychologically impossible. Surrender would mean military occupation by foreign powers for the first time in Japanese history. It would mean the end of the imperial system as it had existed for centuries. It would mean national humiliation on a scale never before experienced. Continuation of the war meant inevitable defeat that was now clearly visible, but it allowed Japan to continue fighting, to maintain honor through resistance, hoping against hope for some dramatic change in circumstances, some miracle or diplomatic breakthrough that would alter the outcome. Commander Yoshikawa, the intelligence officer who had studied those first troubling LST photographs in March 1943, survived the war and the subsequent occupation. In post-war interviews conducted by American military historians, he spoke carefully and diplomatically about his wartime service, as most surviving Japanese officers did when discussing sensitive matters. But he acknowledged frankly that Japanese intelligence services had been aware of American production capabilities and the scale of the LST program relatively early in the conflict. The information had been available through multiple sources. The intelligence had been solid and accurate. What was critically missing was the institutional willingness and psychological capacity to accept what the information actually meant for Japanese strategy and war aims. He described in some detail a meeting in late 1944 where intelligence officers presented comprehensively updated assessments of American naval strength to senior commanders. The numbers were comprehensive and detailed, based on multiple independent sources, carefully cross-referenced and verified to ensure accuracy. They showed that American naval forces had grown to several times their pre-war size in just 3 years of intensive wartime production, while Japanese forces had steadily declined through combat losses and inability to replace them. The officers presenting this sobering information were asked directly what Japan could realistically do to counter such overwhelming and growing capability. After a long, uncomfortable silence in the room, one particularly brave or perhaps simply exhausted officer replied with brutal honesty that nothing could be done at this point. The industrial race was over. Japan had lost that race decisively. The only question remaining was how long the war would continue before the inevitable end. That assessment, stark and brutal in its complete honesty, was emphatically not what military leadership wanted to hear or could publicly accept. But it was the mathematical truth that the LST production numbers, along with all other production data, had been clearly indicating for over a year to anyone willing to see reality without illusions. One nation had successfully mobilized its entire industrial capacity for total war, transforming peacetime factories into weapons production facilities on an unprecedented scale. The other nation, despite tremendous personal courage and sacrifice from its military forces and civilian population, despite sophisticated tactics and determined resistance, simply could not match or even approach that level of industrial mobilization. The outcome had become inevitable. The LSTs themselves continued serving in every theater of the war until the end. They landed American and British troops in Sicily in July 1943. They participated in the Normandy landings on D-Day, June 6, 1944, delivering tanks and troops onto the famous beaches. They supported landings in southern France. They operated throughout the Pacific at every major amphibious operation. They were present at the war's end in both Europe and Asia. After the war ended in August 1945, many LSTs continued in military service for years, providing essential logistical support during the occupation of both Japan and Germany. They transported supplies, equipment, and personnel as both defeated nations were rebuilt under Allied supervision. Some LSTs served in Korea during that conflict in the 1950s, once again proving their worth in amphibious and logistical operations. A few remarkably durable vessels remained in various naval services into the 1960s and even 70s, their simple and robust design proving remarkably long-lived and adaptable to various roles. The men and women who built these ships, the hundreds of thousands of workers in shipyards from Pittsburgh to Portland, from Chicago to Charleston, mostly returned quietly to civilian life after the war ended in 1945. They had been part of something unprecedented in industrial and military history. Though relatively few fully understood the complete scale of what they had collectively accomplished at the time or its historical significance, they had simply gone to work each day during the war years, welded steel plates together, installed electrical systems and equipment, operated cranes and machinery, and launched ships down the ways into the water. The fact that their daily labor had helped fundamentally reshape naval warfare doctrine contributed decisively to victory and demonstrated the power of industrial mobilization was not something most thought about deeply or discussed. They had jobs that needed doing, and they did them to the best of their ability. That was enough. The lesson of the LST program. If there is one clear lesson to be drawn from this history, is not simplistically about the superiority of any particular nation or political system. It is about the essential nature of industrial warfare between modern nations and the terrible mathematics of production capacity when nations mobilize completely for total war. In conflicts between modern industrial nations with access to resources and technology, victory often belongs not primarily to the side with better tactics, or braver soldiers, or more brilliant generals, though those factors certainly matter, but ultimately to the side that can produce more equipment faster and sustain that production over time. Individual courage and tactical skill matter tremendously at the human level, but they cannot overcome sustained material disadvantage when that disadvantage reaches certain critical scales. Japan's admirals and generals witnessed American LST production reach 1,051 ships in just 3 years. They saw reconnaissance photographs showing dozens of vessels. They read intercepted communications. They received detailed intelligence reports. They had the statistics and numbers, but they could not or would not accept what this information clearly meant for Japan's strategic position and the war's ultimate outcome. And in that critical gap between knowledge and comprehension, between seeing evidence clearly and accepting its implications fully, between having information and acting on it, lay one of the war's quietest but most decisive defeats. A defeat of understanding, of imagination, of the ability to accept that the world had changed in fundamental ways. The ships were absolutely real, not propaganda or illusion. The numbers were accurate, verified through multiple independent sources. The conclusion was inescapable to any objective observer. But acknowledging it required admitting that the war was lost, that the sacrifices had been for nothing, that the path chosen had led to disaster. And that admission, for those who had initiated the conflict and led the nation into war, remained psychologically impossible until the very end came in August 1945 with atomic bombs and Soviet invasion and finally surrender.